I'm sorry, I didn't realize I was streaming myself. Let's see. YouTube is not receiving enough video to maintain smooth streaming. I'm sorry, I thought y'all were looking at my starting soon screen. But here you're looking at me being like, what? And moving stuff around. Good morning. Welcome to the stream. Today, plan is to make a PCB for this thing, which you can't see because I've not done setting up my stuff. Reconnected device, okie doke. There we go, boom. Stream, we're making a PCB for this. You can see that I am not using that, I am using this instead. That's because I really like this. I really like this. I think the column stagger experiment was fun. I think the 3D printed keyboard thing, all that stuff, it's all been good fun. But for the most part, Reviung 34 is the jam. It's kind of between that and the Zaphod in terms of like the ideal unibody split for me. I like that the Zaphod has a harder angle between the boards, or between the halves, and also you got the screen. Screen is less important to me. It's very nice, especially because I've got ye old bongo cat on here. And it's nice to see like what Bluetooth profile I'm on, if it's connected, that sort of thing, what the battery level is. Throw all that stuff out. If it's only connected to one device, it doesn't matter what Bluetooth profile it's on. Battery level is either reported to the operating system on iOS or whatever, and Bongo Cat I can live without. It'd be really nice to have a pointer here. Something like, say, a Circ trackpad. And I might get to that. I still want to get back to the Circ trackpad at some point. I need to figure out what the hell I'm doing wrong there. Oh, and that's also not Reviung time. Let's see. Flailing in kicad. Okay. But because I want to take this keyboard, and I don't want to like make it mine so much as like to make it so it's like, oh, I've got my fingerprints on there and it's like my board now. No, it's like, this is great. I need to make a couple changes to like make it up to my spec or whatever. And by my spec, I mean something more like my, whoops. Wow, this is plugged in, it works. What did I just do? The hell? Okay. Does this actually, I mean, it should work, but is it actually, oh wow, it is turned on. I accidentally hit the lock button on this keyboard and everything went blank, and I'm like, the hell's going on? So this is the Ergogen 41 LP. One of the awesome things it has is a power switch and pads for soldering the battery for the battery. I would like to have a JST connector, or at least through-hole pads for the battery leads, but JST connector would be nice. Definitely want to have a power switch, just because when I put this on my backpack, I want to shut it off, because I don't want it to, like, you know, a key being pressed means it's sitting there. It's less about the like noise pollution, the spectrum noise pollution of constantly throwing out Bluetooth, or I don't even know what it would do, but more about the battery drain and stuff like that. And also, like, I don't know if it's true with lithium polymer batteries, but I feel like with alkaline batteries, one of the reasons you get leakage in old remotes and stuff like that is because they get thrown into a box and one of the buttons gets held down. And that drains the battery, like, completely, and I don't really know. I feel like that happens more with old remotes than anything, and it's because there's a button held. So I'm paranoid about buttons getting held. But if I can switch the thing off and just disconnect the battery, then that's fine. So I want to take and make some modifications to the Ergogen 34 to have a power switch, to have battery connector. Ideally, the nice Nano would be flipped over so it's face up, kind of like the more Ergogens. The Ergogen 41 Chalk V2. You can see the nice Nano is face up here. That's because the battery the nice Nano will sit nicely over a 301-230 battery. It's less of a concern if I have a trackpad or something in the middle, because I can stuff the battery under the trackpad. Because I'll want the trackpad to be raised up, not quite to the level of the switches, but higher, so there'll be room under there. But at any rate, I want to make some modifications to this board. But if you saw my stream from way back, where I did basically this exact same thing of walking through part of the AIO3 PCB design thing, I have no idea what the hell I'm doing in kicad. None. So like opening this up or opening up the PCB files for the Ergogen 34 and trying to hack on it, just like, that's my starting point, is it's just not going to work. I need to have a little more background knowledge and stuff like that. So, given that this is kind of backburnered now, like, or not necessarily backburnered, but more like canceled, I guess, in terms of like, am I going to make this a thing that I use long term? I mean, I do want to like see it all the way through, so that's part of the motivation here. It'd be nice to like have an actual, like, here I went from almost zero to a PCB built. This will give me an opportunity to give me a playground for learning more about kicad, and then also going into Ergogen and trying to build a PCB using Ergogen. So looking forward to doing that. And then once I have that, once I have kind of the basic knowledge that I need, either see this through and, get a PCB made for it just to be like, look, I built this. you know, I didn't design it from complete first principles from scratch. I tried to, and that just wasn't working. But I still took it from a starting point and saw it through to a PCB. I lost my train of thought. I'm sorry. This is why sometimes it's fun to watch the stream, because I just go and get lost. I can see the whole. I can just have a documented process of like, look, or not documented process like for someone to follow, but just like I went from this part to finished PCB, and here I have the finished product or whatever. I don't know. Just screw around with it and then learn some about kicad, so then I can maybe hack this up. I was originally planning to hack up the Reviung 41, which here is the stock Reviung 41. Like MX Reviung 41. I wanted to have it with chocks and also pads, and so that's what this was, but I didn't do this. This was somebody else's work. So they would probably do it if I asked them or paid them or whatever. They would probably do that to this, but I want to do it. I want to try it myself. I mean, really, I kind of want to show it on stream and whatever. So good morning, Sadek. Sorry, I saw your messages and did not immediately reply, but good morning. Almost good afternoon. We're getting there. Yeah. Support for Pimoroni trackball in the center. Yeah, I've thought about using the Pimoroni. I had a BlackBerry Pearl, and that little trackball sucked. I had a Mighty Mouse. Remember the Mighty Mouse, the buttonless mouse that Apple came out with years ago? That was just a slug, like a pill bug shaped mouse that had a little, instead of a wheel, it had a ball, and it was buttonless, but you could do left and right buttons because it would figure out like how much weight was being pushed on each side or something like that. Yeah, I had lots of problems. It was probably a different ball, but I had lots of problems with the Apple one. Like, it would just stop responding, and I think it was just like stuff on the ball was getting gummed up inside the works. Just, I just wasn't a huge fan. And I really want to try out the Cirque. I think that'll be better. The nice thing about the Cirques is, one, you can get them pretty big. Like, I've got one here that's like an inch and a half in diameter or something. Like, it's pretty big. It's about the right size to fit over where the Zaphod display would be. And I feel like that's like the perfect position and the perfect size for a touchpad. Since I'm using it with my iPad, I don't really need it that much. I need it for basic, like, I need to highlight some text, so I need to move the pointer to where the text is, and then like have that mode on there where if it's like it detects you're using the touchpad, that it turns your thumb keys into mouse buttons, right? So like quickly grab some text. Like 90% of what I would probably use it for is highlighting text, because that is such a horrible, painful process on iOS, like touching on the screen. Like, you gotta touch and then it's like there's a delay and maybe it's a pain in the ass. Real pain in the ass. Highlight with the mouse or trackpad would be awesome. But that's all I really need it for, because if I want to scroll or if I want to click on something on the screen or something like that, I'm gonna reach up and touch the damn display. Like that's what it's for, right? Maybe if I had a mouse on the keyboard, I would use the touchpad or touchscreen less, but I tell you what, nearly every time I've gone back to using a desktop from using my iPad with a keyboard, I instinctively reach for the screen. So there is something there of like touching the screen makes more sense most of the time. But selecting text is where it doesn't make sense because you just can't. I don't know. It's just a horrible. It always has been a horrible experience, in my opinion, on iOS. Sometimes you can't even do it. I don't know. It's a pain in the ass. But that's all I really need it for. So like the Pimoroni could probably work for that. I just don't like it. I don't know. I haven't used the new Pimoroni modules, but I have used a BlackBerry Pearl, and I have used a similar kind of thing, maybe even the same part, from the Mighty Mouse, and just wasn't a huge fan. So, touchpad it is. I'm a little concerned about battery life with the touchpad because it's capacitive, so it's powered all the time, but you know, that's a bridge crossed when I get there or whatever. Anyways, long story short, today we're going to be probably starting over and walking through this again because I don't remember where I left off. I don't think I have any of the stuff, but fortunately I should have most of the stuff all ready to go. Oh, maybe I even have the Git repo. Yeah. So, walk through this, get far enough so that I kind of like know how to open and modify the PCB in kicad such that I can start messing around with Ergogen to make the PCBs. Kind of what I'm trying to get to. I don't know how far I'm going to get on this today. I imagine this is going to be a multi-day, multi-stream process. If for no other reason, because I've never really worked with kicad before. Other than like what I got through with this. Yes, go have your meeting. Come back when you're done. I hate meetings. I'm glad you're in it and not me, but yeah. Anyways, yeah, so that's where we're gonna get started. I am caffeinated, so I'm a little scatterbrained at the moment, so apologies for that, but we'll see. And the screen, the layout looks really weird right now because it's just like the Safari window is like dead off to the side and stuff, but it'll get better once I have something else to show. I didn't want to full screen the window and then have to screw around with it. So anyways, so grab the requirements, repository prep. Let's see, github.com/kitchen, repos. Let's see, dot files, mykeeb, Ergogen, QMK firmware, ZMK boards. Oh yeah, kicad tutorial. Okay, maybe I do have this ready to go. Something you may not see or note, or you may have noticed but can't quite see. I got a Seed Studio reterminal. It's a Raspberry Pi compute module attached to a PCB with a display and stuff like that. Messing around with it. The reason I haven't done more with it is it comes with Raspberry Pi operating system preloaded, but given that it's like someone else's operating system and it's from, you know, Seed Studio is probably on the up and up, but it's a Chinese company. I don't know, you know, standard practice is you don't use someone else's OS install, I would say. Do it yourself, right? But to install your own operating system on this, you have to take the case off, and then the heat sink off of the Raspberry Pi compute module, and there's a little switch under here you flip, and that changes so it boots off a USB or something. And it's just like, really? You couldn't have put that on the outside of the case somewhere? So I haven't done much with it, but it's a really cool little thing. It's got like a 720p display built in and stuff. It's not battery powered, but that's fine. It's got a quarter 20 mount and what looks like probably VESA adapter. So what I'm probably going to end up doing is getting another little tripod like the one my phone here is mounted on, and stand that next to, or use like a magnetic tripod base or something, and attach it to my 3D printer, and this will be an Octoprint. But anyways, sidetrack. The reason that came up is because I have another display for Raspberry Pi that I think is 1080, or not 1080p. It might be 1080p, but has an HDMI connector. And so I was thinking about using that as a display for my OBS and streaming controls and that sort of thing. So then I could full screen whatever I'm working on and just share the whole screen here, to make it easier for window management and stuff like that, in terms of like showing y'all what I'm doing on my computer, and maybe even so you can see the mouse pointer. I don't know. Yeah. Anyways, I haven't done that yet, obviously. So let's go look at, let's see, kicad tutorial. Oh yeah, I do have it. Okay, that's not what I was looking for when I was looking for it. So let me open project. Let me get this up here real quick. Oh, because it's not in there. There we go. All right, kicad PCB, schematic, window capture, kicad main. Yoink. All right, we're getting there. Boom. Okay, so there's my kicad window. So this is where I left off last time. Let me see if I can catch that up in here. Create an MCU schematic. So I think we worked on that a little bit last time. Schematic layout editor. Yes. All right. I'm gonna have this overlap just a little bit. Because you don't really need to see the menu on the left here, but seeing more of the schematic editor is nice. Okay, so this is where I left off. So the schematic editing part makes a lot of sense to me. Basically, I think what they're trying to make you do here is you make the schematic first. And then you say like, okay, well, this is a, whatever diode. This is whatever switch. You assign footprints and stuff like that. And then you can lay it out on the board, on the actual PCB. and it automatically has these connectors like pre-wired, or at least like flagged that you need to route them. And so you have this kind of like checklist of things you have to do. And so then you also have your schematic and your PCB at the same time, so you can kind of see that they're both the same. This seems like a really great way to do it. And like it has, you know, these are kind of like buses, or just kind of like, you know, what is D plus? No, like call 0, call 1, row 0, row 1. You attach those to various pins over here, but they can be separate in your schematic, but they're kind of like symbolic things. Like, okay, well, this is call 0, that's unique. So this pin on this controller is connected to, or on this component, not even controller, just this pin on this component is connected to call 0, and call 0 is connected to all these other pins. And then, yeah, maybe a bus is the wrong way to put it, but that's kind of how I think about it. It's like the ground bus, the VCC bus, because I think about it in terms of like a breadboard, where that's what these are, positive and negative bus bars, basically. So, anyways. Beginning the schematic. So we got this part, ground. See, and this is going more into, so this is going into like embedded controller as well, which I won't be doing, at least not for this first round of it. I'd be using a Pro Micro footprint. In the future, I might try it with an embedded controller, but yeah. No, so I set up this schematic that we're looking at right now months before I even started with Ergogen. So originally this came from, I was gonna open up the Reviung 41 PCB in kicad and go, okay, I'm gonna change out the footprints with chocks. And I got in there and I'm like, I have no idea what the hell I'm doing. None whatsoever. I need to go back to square one and try this. So I started going through this tutorial, and that's where this schematic came from. Yes. So yeah. So this is, aside from the, like, eventually we're going to have call 0, call 1, row 0, row 1, and those are going to get wired to pins on the controller over here. So most of the rest of this stuff can just kind of get ignored and seen as Pro Micro footprint, because there is like a Pro Micro footprint, or Pro Micro, you know, you can just drop one into kicad and be like, here you go. Here's a Pro Micro. Here's all the pinouts for it and stuff like that. Wired up, and it has all this stuff on board. This is kind of like building the Pro Micro from scratch, and then attaching stuff to it. So, but it's not really a Pro Micro. It's just the, you know, a Pro Micro contains, like, the official Pro Micro has an Atmega 32U4 controller on it. Like this, that's what this black little square is here. And it has all these other components too, probably, or whatever it needs for that. But the matrix and, whoops, did not mean to do that. The matrix and the pins on the controller, because ultimately the pins on the Pro Micro actually map to pins on the actual controller IC. So, yeah. So decoupling capacitors, I don't know what any of that means, but we go with it. Then it wires up the crystal. Reset button. ARF pin is ignored since we won't be using analog readings. Okay. Now let's place the global nets on the USB lines. Okay, I see. And those are coming from D plus and D minus are coming from USB. Okay. View of the completed MCU zone. Now it's time to complete the rest. Okay, so I did get past that part. So then it says USB circuitry on a typical mini B USB will be covered, or only typical mini B USB will be covered here for simplicity. Type C setups will be discussed in future sections. So search for the Molex USB connector in my library, which is here. Okay, so it's got a polyfuse on the positive. Switch matrix. Okay, we've got the switch matrix wired up. Drag a wire across the diode cathode and call pins of each row and column and terminate them using the hotkey K. Finally, add global labels for each row and column. Okay. Note that we'll not be connecting to the rows and columns to the MCU just yet. Okay, so this is the assigning footprints part. Now the electrical setup's complete. However, kicad doesn't know how to translate this to physical form. So let's input the data. Assign PCB footprints to schematic option. Some of this I'm trying to play catch up to where I was. Assign, okay, so that's, oh no, that is the same thing. Okay, that pops up a different window, which you probably can't see. Let me see if I can make that show up. Not that one. There we go. Okay. Oh, wow, that's huge. So this pops up. Okay, and I think I did some of this stuff previously as well, now that I look at it, because it says, like, here are the components that are in the schematic. What are the footprints that are assigned to them? Larger boards, you'll want to at least manually name each switch. Exporting the net list requires a completely annotated schematic. Build the PCB. Okay, so we actually are done with that part already. So let's, whoops. Get rid of that. Transition. Okay. Alright, so it wants us to open the PCB now. First, let's adjust the grid so it's fine-tuned for making keyboards. Okay. Let me get the PCB window up on the stream. Okay. On the left pane, switch the units to millimeters. Done. Open the grid settings menu. User grid. No, it says, oh yeah, set the grid, custom grid size to 0.79375 millimeters. Okay. Done. Set fast switching values to custom and 5 mils. Oh, I see. That's in the... There we go. Custom and 5 mils. Okay. Test grid switching by holding the key combinations Alt-1 and Alt-2 in PCB Editor. Alt-1, Alt-2. Okay, that works. Also, this is a nice chance to tune graphic settings to your liking since you'll be staring at the screen for a while. In preferences common? Okay. Super sampling. High quality. Anti-aliasing. Sure. I hope it blows up the GPU. This thing has like a 90 core GPU in it. Preferences. Display options. You can change how the grid is displayed. Suggest using lines rather than dots. Okay. So then update PCB from schematic button right up here. Okay. Keep existing, so netlist update successful. Boom, update PCB. Doing so will barf out all the components onto the PCB. It did not. Why is this moving on its own? Or is it like still working on importing the stuff in? Items? I see. Update footprints, delete extra footprints, update PCB. Close. Well, I'm gonna make this a little bit smaller on my side and a little bigger for y'all. There we go. I don't know why that horizontal scroll bar is doing its own thing. It's like, by the way, I'm gonna just move for no reason. Okay, so let's go past this and see. So it says switch to grid 1. What does that mean? I think that means this. So, yeah, that's the user grid 1. Click component MX1, but there is no component MX1. I don't see it on here. What is this? Redraw screen, zoom to fit board or page. All right, let me take a step back from this real quick. Discard changes. Maybe we need to save changes here. There shouldn't be any changes. How about I delete that? And then we'll... PCB layout editor. PCB doesn't exist. Do you want to create it? Yes. Okay. So we're starting with a blank PCB. Let's get the PCB window back up. Is that this new one? No, it's not. This is something that's frustrating about OBS. This is why I really want to make it so you just see my whole screen. Because, like, micromanaging what windows are being shown to you is a pain in the ass. Because, like, you might say, oh, well, Stream Deck. Well, yes. Because I can make it do things. But I can't, like, if I close a window... Like, if I close this PCB window right now, you still, you don't see it. You don't even see it. If I close this PCB window right now on my end, you still see it even though it doesn't exist anymore. If I then bring up a new one, that is a different window than was previously being shown. So I have to go into the OBS settings and, like, change which window is being shown, even though it's basically the same window, but it's not. So I have to do that every time a window changes, and it's yeah. Anyways, hashtag first world problems. Okay, so went to new PCB. We've got our user grid set up. We've got set to millimeters. We've done the display options stuff. Click the import PCB data icon from the top. Oh, I have to import it first, then update. Import data from the schematic. Where is that? It's frustrating that these tooltips take so long to show up. Save board setup? No. Open footprint editor, open footprint viewer, load net list, update PCB from schematic. Or no, that's right. Import PCB data icon, then select the update PCB button. Okay. Keep existing symbol to footprint association, update footprints, and delete extra footprints and update PCB. Update PCB. Doing so will barf out components onto the PCB. Dirty, dirty lies. Maybe I didn't. Let's go discard this. Let's go back to the schematic. Okay. So let's go back a page here. Assign footprints. Assign footprints to schematic option. Okay. I have to export the net file. The wiki doesn't mention that. Unless, wait. Nope. Then footprint data has been exported, but it doesn't say to export the net file. Save schematic, continue once done, then close the dialog. Generate netlist, is that what I need to click? Okay, so generate netlist and just save it. Then go to the new PCB. So I load netlist and then update PCB from schematic. Okay, so I loaded the net list. Get nothing. Then update PCB, close. And still I don't see anything, although it's hard. The scroll bars are moving on their own again. Let me just look at this net file here. Oh god. This netlist file, or this .net file, is seemingly a Lisp variant of some sort. Alright, I'm going to save this PCB file and then look at it. Okay, so the PCB file does have the components in it. And it even says like where they're at. Let me pull up iTerms so you can see what I'm looking at. Move to top. There. So, like, this is the untitled.kicad PCB file, which, there, okay. And as you can see, it looks like a Lisp variant of some sort because it's got a bunch of parentheses. That's fine. But it's got these MX. So it's got MX Alps hybrid, yada, yada, yada. It's got all that stuff in there. But KiCad itself is not displaying it. Is my KiCad just broken? It's 5110. Now that's just the layers manager. What's this? Microwave toolbar. High contrast display. Show tracks and outline. Show vias and outline. Show pads and outline. I don't even see a grid. What the hell am I doing wrong? No. Okay, so I clicked load netlist. Then I get this pop-up here. Okay. I get this window. So it has the netlist file. That's the one I saved out from the schematic editor. It's got parts in here. Let's just do reassociate for grins. Or not. I don't know. Changes made cannot be undone. Are you sure you want to update the PCB? Yes. Okay, so that did something. Close. Nothing. So update PCB from schematic. See, I think this update PCB from schematic, I think it does that save the netlist, import the netlist for you kind of in the background. But that's fine because neither process worked. Doing so will barf out all the components onto the PCB. I got nothing. What if I just maximize this or full screen this? That doesn't work at all. That doesn't work at all. Shit. Oh dear. I need to close kicad real quick, and I can't do it. I done killed kicad. Quit. Discard changes. Okay. Sorry, I full screened the PCB editor window and everything went to hell. And the music stopped because it got to the end of the track. Memoir Collections 3. Okay, let's transition. Okay, so we're back open to kicad, and you can see it now. So I'm just gonna go ahead and just delete the net file, just for grins. Delete the PCB file, just for grins. Let's open the schematic. Okay, so kicad schematic. Is this the correct window? Yes. Okay. So you can see this is the schematic. If we click on wait, run PCB new to layout printed circuit board. Huh, okay. But let's see. Assign PCB footprints to schematics. Okay. And this is going to take a second because it's loading the footprint libraries. Okay, so there we go. So footprint assignments. View footprint assignment. Okay, so each component has a footprint assignment. Okay, apply, save schematic, and continue. Close this. We'll get rid of that. Okay, I'm going to run PCB new to layout printed circuit board. Yes, create it. Okay. So now we've got our PCB window up. Maybe. PCB window up. So update PCB from schematic. Close. Okay, so I have a couple of compounding frustrations going on right now. One is that kicad is not doing what I'm expecting. That's obviously super frustrating. The other is that I'm fucking around with OBS way too much. Or rather, I'm having to, just to show you what I'm doing. So, like, I kind of want to do something different right now and come back to this when I prioritize getting that other Raspberry Pi display going. At this point, I gotta find it. I don't even know where it is. Because this is, you know, it's one of those things like, you know, keep doing the same thing and expect different results. Okay. But then, like I said, it's being compounded by messing around with OBS. So, yeah. But I'm not going to completely abandon kicad right now. What I think I'm going to do is we're going to go even simpler. Screw a keyboard. I want a light switch. I want to make a PCB for a light switch. So let me get out of all this crap. And then we're going to go to kicad and we're going to go new projects. Light switch. Okay. All right. Is that what you're seeing? It is not. So, kicad main. Transition. Light switch. Schematic. Here we go. Back to basics. Let's see if we can do a schematic for a light switch. Or a thing. There. Okay. So what I want to do is, where's my symbol? Oh, great. Okay. So I want a switch. It's PST. MCU schematic. So I'm gonna ignore the MCU part and just remember the, like, press A to open the add symbol menu. SPST. There we go. There's a light switch. Another A to add symbol, and we'll go lamp. Okay. Boom. Now, how do I move this? There. Okay. So, and then we'll do a battery. Dinner time in Italy. Enjoy. I feel like dinner time in Italy is one of those, like, I won't see you for a week things. Okay. So, Begin drawing a wire connection. Whoops. Nope. Cancel. Begin drawing a wire connection. So I want to wire that to there. This to here. And this to there. Want to get rid of delete wire. Okay. So there's our very, very simple circuit. Really, really simple. It's a light switch. Okay, so we wired everything up. Complete the rest. Okay. Assigning footprints. Electrical setup is complete. Now, however, kicad doesn't know how to translate this physical form. Let's input the data. So assign footprints to schematic symbols. Exporting the net list requires a completely annotated schematic. I'll ask you to annotate the schematic. Okay, so I see it automatically numbered those for me. Okay. View footprint. It doesn't have a footprint for that, okay. Footprint libraries. Button switch keyboard? Nope. Well, actually, we will just make it a keyboard switch. Why not? Button switch keyboard. Cherry MX switch. Oh, wait. Okay, and lamp, we'll make it an LED. Through hole. $9 p.m. What are you talking about? It's 1 o'clock. Apply, save schematic, and continue. There we go. Okay. I don't know if that worked, but we'll try it. Bill materials. No? Okay. Edit symbol fields. Okay, okay. That looks to be sure. Let's open this in the editor. See, even a simple PCB like this isn't working. And I bet you it's some sort of friggin' Mac OS permissions thing that PCB new doesn't have access to open stuff. or something like that. And it's because kicad is unsigned, and it's this. PCB window problem. Entirely gray, tried different products. Problem solved. Change to legacy toolset. Sorry, you didn't see that pop up. The PCB new crashed. So what do I do? Tall. Not supported in the legacy toolset. I think we're getting closer though. Modern tool set. Okay, where are my components? Oh, wait. Here, update PCB, close. What do we have here? Oh my god, the zoom behavior is terrible. And how do I drag the friggin' window? Okay, take this all the way to the upper left. Zoom. 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 Damn it, not zoom to center, zoom to mouse pointer. Okay. That's not what I freaking... But, so how do I zoom on this? Because if I move my mouse pointer over the component and zoom in, it moves the mouse pointer to the center of the window. and zooms in on the center. Which, okay. But how do I move the friggin... How do I pan if I right-click and move? And none of this makes any sense. Like if I... Okay, so I have it zoomed to selection, right? If I select that, it doesn't zoom to that. It's zoomed to friggin' the corner. Or something. Honestly, at this point, I'm just happy I can see components on the PCB. Like, this is progress. I can't double click, I can't right click, I can... Even if I go right click center, it doesn't do it. So there's something isn't right here, but that's okay. I'll just move the whole all the components. Wait. See, now it's doing what I wanted it to do. Which is zoom to where the mouse pointer is. Okay, anyways, we've got display stuff. So I'm gonna... Oh, and you can't see any of this. Oh, I'm so sorry. You can't see any of this progress I just made. Okay, I am prioritizing making... I'm going to prioritize getting a second display going for this, because this is ridiculous. This faffing about with window management on my desktop and also in OBS. I need to do something about it. But it's not going to happen today, or at least it's not going to happen during the stream. So, but yes, I finally now have components on it. Wow, that looks really weird on on the display, or on the stream, because of the grid and aligning it, and it's taking a 5K display and stuffing it into a 1080p render and streaming it out, and okay. Yeah, nested ternary operators are evil. I agree. Ternary operators are kind of evil on their own, but they can be very handy if used sparingly. But nested, absolutely not. If you're doing nested ternary operators, you need to break that logic out into a function or something. Like, that's just ridiculous. Yeah, don't. Just say Kitchen says don't fucking use nested ternary operators. Just, that's all that anybody has to... I can even go so far as to tweet it if you want, and then you can cite the tweet, be like, look, this is what Kitchen says. He agrees. I don't know what a comma operator is in JavaScript. I know what a comma operator is in Perl, because a comma operator is just a comma is... What am I trying to say? In Perl, a comma is equivalent to a different operator. Or maybe a different operator is equivalent to a comma. Oh, a hash, not a hash rocket, but a fat arrow is equivalent to a comma in Perl. They're the same thing. Yeah, I mean, you said JSX, so I like JSX. I think when I first heard, like, let's take XML and embed it into JavaScript, I was like, you just said 3 things that should never go together ever. And then I was using it for, we were doing I don't know if it was React. I don't think it was React, but it was Stripe internal UI thing that we were working with that used JSX templates. And I was like, you know what? I take it back. Java having XML literals is so much better than this quoted shit. Because it's just an XML literal. It's just a string of XML that is... Because XML, if you think about it in the right way, is just kind of an object, right? So... here you go. Here's XML syntax of an object. And if you're manipulating the DOM and stuff like that, there you go. That's you want to inject XML, things into the DOM. But yeah. I don't know what you're talking about with the comma operator, but I'm gonna just not. Yeah. Okay, so I'm gonna circle back to... We're gonna go back to the other one now that I've made some progress. Open project. KiCad tutorial. Let's see. Let's get it back to where you can see things. So we're in the KiCad tutorial. Let's click on Open PCB, create it. I have a PCB window that actually has a grid on it now. Let me make this visible. There's a grid. Update, update, close. There we go. That is what I'm supposed to be seeing here. That is almost literally the same thing. Great. Progress has been made. So, for those of you who, because nobody saw what I was doing, I was looking at Reddit, all this stuff. There's some in the preferences window, or in the preferences in PCB new, but not the preferences window. So on Mac OS, you go to the next to the Apple menu, there's the applications main menu, and you go down to preferences. The same thing, Command comma, if you're familiar with those keyboard shortcuts. That's the main application preferences thing, right? But there's also a preferences menu in KiCad, and that preferences menu has a legacy toolset and has a modern toolset accelerated. And someone was suggesting to switch to the legacy toolset, but apparently I was on the legacy toolset. When I switched to modern toolset, suddenly I had a grid, and then suddenly I was able to see components in the PCB. So here we have, hooray, hooray, so excited, the PCB. Let me futz around with this just a little bit so we can see it side by side. And like I said, yes, I will for next time have so I just show my full screen. Means I need to change my background so it's not a giant dick butt. And get rid of all the crap on all the screenshots on my desktop. Okay. First, let's position our switches. Switch to grid 1. So, grid 1. So that's command or alt 1. Okay, so there's grid 2, grid 1. click the component MX1 and hit M to move. So click component MX1, M to move. Nope, that's not right. Oh wait, now I've got all these things over here too. Whoops, okay. When I was flailing around with this, I clicked a bunch of buttons on the side, and now I need to make sure they're... Okay. Selection, select MX1. M to move the whole thing. Press M without the cursor over the component to make sure the cursor is locked to the center of the footprint rather than to the pad of the footprint. Use Control F to find a component if too lazy to find it with your eyes. Okay, place it down on a blank space on the PCB. Boom. Okay. Now place the rest of the switches so the order matches the schematic and the outline overlaps perfectly. This should be easy with grid 1. Okay. So, 1, 2, 3, 4. I'll zoom in here, move that, move this, move that. Perfect. Okay, so 1, 2, 3, 4. Place D1 to D4 close to their respective switches. Okay. There's D1 or D3, D2, D1. I can see why that search functionality would be really handy. D4, okay. So let's just grab all of these and move them a little closer. And then fine tune here. To rotate footprints, use R. Nice. R, 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 M. So there's M1, 2, 3, 4. Place them facing downward as shown. Okay. Now to position microcontroller components. This is easier done in grid 2. Select 32U4, place it to the side of the matrix somewhere. Grid 2. Let's move the controller. No, that's not what I said. Move it. No. Wait, that isn't snapping to grid? Or it's snapping to a finer grid than I have. Whoops. Okay. That explains, okay, so what just happened right there explains why I was getting the phantom scroll bars, because the PCB was actually there, but I couldn't see it. It wasn't rendering it. And so when I first did the import update PCB from Schematic, it selected all of that stuff and like had it so I could just click on it and drop it onto the board. But since I couldn't see it, I didn't see that was happening, that I had a selection. And so like what I did right here, if I hit M here to drag this around, it will automatically scroll for me when I move to the edge of the screen. Or to the edge of the window. I'm not touching the mouse buttons. I'm just... So it's like, that's very handy. But what was happening then is I had a selected component, or in this case, a bunch of selected components. And because I was moving around to try to figure out what the fuck, it was like, oh, you're trying to scroll this thing you can't see. And that's what was going on. Okay. See, we're learning. You learn through failure, right? Okay. And then, so it's like, okay, move the PCB, or the controller, place it inside a matrix, place the crystal close to the crystal pins on the MCU. Crystal is here. Okay. So I was about to say, it's a little weird that it's like showing this as a different... So my crystal pins appear to be on the south side of the board, or of the controller. Whereas it's showing them on the top, but it's probably just they've rotated the thing. Let's open this in new tab and get a little zoom on it. So that's pin 12, 13 across the top. What do we have here? Yeah, so theirs is just rotated. So let me just rotate mine to match. Maybe. Oh, and it's flipped. Like reversed. Maybe their view is from the bottom or something? I don't know. At any rate, I'm going to then move this. Whoops, not what I wanted to do. I'm going to move this. Not what I wanted to do. Move that to like here. Try to make it match what it says. Do they have it on the other side of the PCB? I'm guessing so. I don't know. Wait, what was that I just closed? Oh, okay. Oh, okay. We would be placing all surface mount components on the bottom side. To flip the components between sides, use the F hotkey. If only I had read things. So F, okay. Let's rotate this. There we go. That's better. That looks more like it. Okay. But that means I need all of this stuff to get flipped. And does that mean this needs to get flipped too? The diodes? F? Oops. Footprint D1. There we go. Okay, rotate. Okay, yep, it does mean that. So let's move this over here, flip it, rotate it, move it back. Let's change to the other grid. Okay, move this, flip, rotate, move back. See, I'm already becoming pro at this. All right. If only I could figure out then how to, besides, I guess, middle click drag. Okay. Let's actually get this a little closer to here, just for ease. Select 32U4. You need to see which pins need to be connected. Control click a pad. Place the load capacitors for the crystal as well. So that's the it says Y1. Oh, wait. Instead of looking at the screenshot of the schematic, let me look at the actual schematic. Open schematic in eSchema. Basically, I don't know what the hell they're talking about when they say the load capacitors for the crystal. I don't know enough about these to know what components are necessary. Whoops, okay. Now, wait, is that literally just the same? No, it's not, okay. This needs to move order up. And that's not the right window. Okay. So I think these are the capacitors C5 and C6 for the but see, this is showing 4. Place each. Oh, wait. I see. Place each of the 0.1 microfarad decoupling capacitors near the VCC ground pin pairs on the MCU. So that's what these C1, 2, 3, 4 are, the decoupling capacitors. Or, yeah. I also have too many windows going on here. So C1, 2, 3, 4. Excuse me. Excuse me. Okay, and then I want to select these, reverse and flip, or not rotate and flip, just flip. Okay. Does it even want the switch on the bottom? The reset switch? I guess that makes sense. Okay. Flip. Flip. There we go. Move that to there. Flip that. Flip that. Move that to there. Rotate. Move that to there. Ah! There we go. Perfect. And then actually we'll flip this, move it to there. Sure. There's our PCB. Ship it. Okay. Next step's routing. First, we need to adjust some settings. Yeah, theirs looks way better than mine, but that's fine. Because I'm not super concerned right now with understanding the actual circuit that the controller is, because to me, in my world, that is a black box. That's just a, here, throw this in here. All of this crap is this. It is a drop a footprint in here, wire to the matrix. For now, at some point, I will probably want to learn more about this and all this stuff. But for now, I don't care. So if it looks fugly, I just don't care. Okay, so routing. Plus, like it says, you can always adjust positions during routing. So I got it so, at least there's like direct pin. Hopefully things aren't crossing too much. Whatever. Even though, like, it doesn't really matter which side those go on, I don't think. Like, if I rotate this, rotate, yeah, whatever. It probably, yeah. Okay, so switch to inches and open the board setup menu. Board setup. Okay. Window you can't see. So by default, tracks are roughly 10 mil wide. However, always good practice to route power traces thicker whenever possible. Add a new net class named power. Net class. And we're actually going to show this. Board setup. Boink. Transition. Okay, so net class named power. Set track widths to 15 mils. Okay. Using the list on the bottom, assign the power class to nets VCC ground and plus 5V. So VCC ground plus 5V. Okay. Assign net class power to selected nets. Okay. I see. So net class power, power, power. This is really cool. Press OK to confirm changes. Now the remainder is connecting all the pads to the same net. Use trace tool, click one pad to begin, another pad to end. Clicking empty spaces will create corners. Few important points when doing so. You can route traces on both top and bottom side. Press V when not routing to switch between top and bottom. Press V while routing to drop a via or drill a hole that allows you to jump between layers. My usual choice, generally route verticals on top, horizontals on bottom. Okay. Cool. I'm going to YOLO this. There's auto routing, right? Isn't there a way to like click and route all this for you? Well, first I'm going to save. Save. Then I want to auto route just to see how bad it is. Route single track interactive router settings. Okay, that's not what I wanted, but that works. Differential pair. I don't even know what that means. Unable to find complementary differential pair nets. Whatever. Okay. This is going to be the world's best routing job. I'll tell you that. Wow, this is connected to a lot of pins. I guess it's like plus 5 volts, isn't it? Okay. Oh no, it's ground. Okay. I probably shouldn't have started with ground. YOLO. All right, so click, 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 click. Oh my. Okay, so click here to here. Oh yeah, it's telling me it can't get through. Nope. Or maybe it has to go to the other side? No, it's just telling me it can't get through. Okay, so let's... Can I delete that track? Let's see. Undo. There. So we're going to go here. We're going to via... Click. Click. Via back. Click. Then click here to here. Whoops. Here to here and here. Oh, are you kidding me? Okay, I want to take this ground that's screwing everything up and bring it inside here, I think. How do I select that track? This one. Can I select the whole damn thing? So single track is Shift X. Okay. Let's go. There to there. What a disaster. Okay. So what this is telling me is I need to organize this a little better. So yeah, I'm actually... This is hard. It's not an easy problem. Track that. Delete this. Highlight net. Does this, what does this do? Route tracks. Add vias. Highlight net. Can I just delete the whole net at once? Click. I can't. But this is nice, because it stays up here. Oh, and I don't have to click on it to delete. I can just hover. Whoops. Undo that. Edit. Undo. Okay. Delete the track. Delete the track. Delete. Delete. Undo. Why does that not work? There we go. Delete. Frig. Music's dead again. Damn it. Undo. Why does that keystroke not work? So I will say that I don't have to click on something to delete it. Sometimes it's better to, because it disambiguates what I'm selecting or what I'm about to delete, which I think for traces is probably nice. I kind of wish I could just delete the whole track. Okay. Actually, can I just delete all tracks? Route. Interactive router settings. Highlight collisions. Jump over obstacles. Oh! Remove redundant tracks. Optimize pad connections. Mouse drag behavior. Move. Shove. Okay. Okay. Nifty. Learning. Okay. Delete that. Delete that. Do I really need to have all of these plus 5V pins wired up? Aren't they all wired inside the controller? Not gonna lie, y'all, this part is really hard. And I don't mean the deleting everything, I mean just routing in general. But I think I'm starting to learn enough here to be dangerous. What if I rotate this? Rotate footprint. Oh, shit. Here I'm doing all this routing and stuff, and it's hidden behind this window that I can't see anymore. Sorry. Like I said, next time I will have it so I have my controls on a different display so that what I'm looking at is what you're seeing. Okay, so that's fine because that's crossing those two pins and ground is connected there. So I can take ground from the controller and go back to there. So let me just route this one real quick. Shift X. Boom. 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 Oh, okay. I'll even go so far as to rotate that. Oh. What? So if I... Oh, that's annoying. If I change... Never mind. What I was going to say is that's annoying, because if I change the footprint, the routing breaks. It doesn't reroute it, but that kind of makes sense. So it's fine. So this is crossing all plus 5V and ground. Right? This 1 microfarad capacitor. No. C7 is crossing... Okay. So we're going to move this here. And that's not going to work because it's going through the pins there, but I'm just moving it out of the way for a minute. And let's rotate this. This would be better not inside this footprint or inside here, but it would be better like right here. So let me actually... Let me do this by putting all the stuff really close to where their pins are. And getting everything spread further apart. Okay. So we move this here. Now I want the whole footprint. Okay. And I want to rotate that like that, because that just crosses those two right there. Boom. Then I can route this here to there and here to there. That one's done. Like, there's no other place that needs to move to. That's perfectly fine. Okay. Okay, and so this crosses those two pins. So that is, there's no reason that can't just be right there. Like that. Okay. Reset switch crosses. Okay, I see. So this pulls up the reset. Pin. And then this is the actual reset switch. So undo that. Go selection here. Okay, well, reset switch is actually... Let's just move this off to the side for a minute. So these capacitors cross okay, where's my VCC, my plus 5 volt ground capacitors? plus 5-volt ground. So I'm going to put those right here next to this one, because they can kind of stretch around it. Okay, and then what I'll do is I will route these all together. Undo. Okay. And then I will do that to there. And we'll grab ground, tie these all together. Okay, and then we'll grab this ground and tie it around to there. Okay. Can I hide certain... nets? Like, I don't want to see ground. Because ground is automatically trying to select other places, and it's like, no. Like, it doesn't need to be connected to here, it just needs to be connected to ground, which I can get from over here. And if I move the component over there, then it all changes and makes more sense. Okay, so that just needs to cross. So this crosses 17 in ground. Where's 17 going? C5 pad 1, C5 pad 1, C6 pad 1. Okay. Rotate this. Okay. Then I can click here, move this up to here. This is much better. Move this down to here. Okay, and then I just have to figure out how to get C6 pad 1, so because that's here and here, and then ground is there, but I can get ground from over here. Is it bad to do this? To route through the middle like that? I think it's fine. So then what I can do is I'm gonna move this so it's straight across. Or that way at least. Go there, and then I can grab ground from over here. Okay, go this way. This way. And then I can do this, this, this. Like that. It's so much better. Now I can take this and move it over to here. Rotate. Rotate, rotate. There we go. Route this here. Whoops. Nope. Nope, 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 nope. Undo that. Undo. Whatever. Okay. Then I can Shift X. This. Shift X. That. So, okay. So the data in pins, oh God, really? So the data in pins are in the middle here. I'm just gonna via those through under the controller. So, okay, we got plus 5 volt here. And then we've got ground goes directly to there. These are crossed. Okay, so we'll move those up really close. Here. Okay, like that. Okay, so this is where it's frustrating because I'm like, oh, but it's crossing there, but it's not because that's this line is not the close, not the this can go over here, right? And this comes over here, and then this goes to that. There. Now they're not crossing. So I want to go over to here and drop a via there, go to the other side, drop another via here, and come back to that. This is probably some massive faux pas, but I don't care because, again, I am not generally getting this deep into the guts of the controller. I'm just trying to think about how I could improve on that without using vias. And I'm not really sure. But one thing I do like is that despite all this stuff, I'm not passing the main power through the controller to get to the decoupling capacitors, or to get to these capacitors. That's straight off of the USB port. So it's going through here first and then to that. I don't know if that is a distinction that's, you know, necessary or whatever, but like, I know that like not all 5V pins, not all ground pins are created equal. Like, you got to think about where the power is passing through, and if it's like, okay, and it's passing through the IC before it gets to the protection circuit, it's like, okay, great. That isn't too much. Or, you know, that's just, it's going to fry the IC before it gets to the protection circuit. And I know that fuse is there for that, but like, yeah. Okay, so I will say I learned a lot about how this controller is set up. I still don't know what all these components do. This is, I'm sure, these resistors, I am sure, just like to provide some resistance on the data lines. Sure. This stuff is for protection and cleaning up the signal coming from the USB, the VCC, and turning it into a clean plus 5 volt signal. We've got the clock circuit, which is what actually powers the crystal circuit, which is actually what sets it's a clock reference for the controller. We've got this 10k ohm resistor, which I don't know what the hell it does, but it's there. We've got the power switch, or the reset switch, which is pulled up with this resistor so that it's always hot, but it's high resistance, so it doesn't drain power or something. I don't know. It's just pulled up, and then you cross it to ground or short it to ground, and you got your data lines. Okay, this is starting to make a lot more sense. Now I understand a little more about what these components do when I look at like one of these controllers, or I mean, this has a lot more stuff than that. But like the Faunch pad or whatever, which, speaking of Faunch pad, I got mine back. So I mailed it off a couple of months ago to Critis. Maybe it was a month ago, I don't know. Because he was going to take a stab at fixing it. And he apparently managed to do that. And it now is functional. He sent it back to me. I don't remember what all he said he had to do, but he had to resolder the crystal and stuff like that. Like, yeah. I do think it's funny. I wonder, you know, looking at this circuit here, or looking at this PCB here, well, one, I'm missing a switch because I accidentally deleted it looks like. Can I fix that? Update PCB? Close? Ha ha ha! That's awesome. I can just bring that right back. That's cool. Anyways, uh, looking at this, it's, you know, a 2x2 matrix, and there's all these extra pins. I mean, these aren't, it's not wired up to the controller pins yet, but like, there's a ton of pins on here. Even with this, even with the Pro Micro, which is not exposing all of the pins on the Atmega to the outer pins, you know, a simple 4-key pad, like even a Arduino Xiao has enough, or footprint has enough, enough pins to direct wire an 8-key macro pad. That's what this is. This is an 8-key macro pad that is direct wired to a Arduino Xiao. But I think it's funny, there are diodes on this, which means I'm assuming it's a matrix, but it might be direct wired. But either way, it doesn't need diodes. Well, it needs diodes if it's a matrix. But it wouldn't need diodes if it's direct wired, and there are plenty of pins to direct wire this, so you don't need the diodes. I imagine Germ looks back at this sometimes and is just like, yep, I know. And yeah, I changed that in the future or something like that. Like she's just like, yeah, no, I know, I didn't need to make that a matrix, or maybe it was an experiment in making a matrix keyboard. I don't know. It doesn't matter. It's funny. Yeah. I actually have a faux paintbrush artsy keyboard that I have, which has almost exact layout to this, except it's a little staggered. That is 8 pins to a Pro Micro. Anyways, this I'm really, really glad I got past that stupid tool set thing. Oh, it was really frustrating because I was like, I don't even know what's going on. And this is definitely Fisher Price, my first routing. But it's, I mean, other than it's just like, you know, bog standard traces, and there's no, everything's kind of too spread out or whatever. Like, there's definitely some efficiency gains to be had here. I don't think it's terrible. It should probably work. I think having vias under the controller isn't probably that uncommon or terrible of an idea. The only time you would want to not do that is if your controller had a ground plane underneath of it. But generally, I would imagine that's in the footprint if it does. Ground plane or heatsink or something like that. Some sort of like metal pad on the bottom, because that might touch the vias. Because the vias, I think they do have masking over them, but it's still just, you know, don't. I could have made the vias be outside instead of under. They could have been out here. See, now you got me thinking more. One, I've got an extraneous trace here. That can go away. But I could have had the vias out here. They just need to get inside of this rat's nest here. Without like going down the middle of this tunnel of crazy. But I really like how it automatically set the trace width for me based on the nets it was connected to. That's really cool. Like, ridiculously cool. Um, Yeah. I'm just staring at it and being like, could I move the crystal circuit around over to the side here and clean that up a little bit? And maybe it'd make it more compact, but like, it wouldn't matter. I can definitely make this smaller by moving stuff around, but I don't feel like it. I think this is not bad for my first stab at doing routing. Now I'm gonna post this screenshot up onto up onto Discord and probably the Absalom Club server and be like, all right, um, shame my, or not shame, but review my stuff. You know what? Now, okay, so now that I'm looking at this, I see these unconnected ground and 5-volt pins in here. And in my brain, those don't need to be connected because they're being connected through the controller. But I don't know if that is the way it should be. This one doesn't need to be connected because I think that's... This one doesn't need to be connected because it's not being used. This one doesn't need to be connected. These two don't need to be connected, but like, I should probably connect... You know what, actually, what I'm going to do is instead of connecting this ground pin to this ground pin, I'm just going to move this component here. So let me change this. I'm just going to move this to here. We'll rotate it. It's funny, it's a polarized footprint on a non-polarized component. But this way, there's no there. Okay, so then connect I want to connect plus 5-volt here. This doesn't really need to be... This ground should probably be connected though. Or actually, I can do it under the controller like that. I could have done it around the outside to here. In fact, yeah, let me do that. The reason I would do that, whoops. I don't know what just happened. I hit undo and it did that. But the reason I want to do that is because then if I need to route VC or plus 5V inside here, like ground goes around the outside, plus 5-volt stays in the middle rather than trying to cross them all in here. So I can just do Command X or Shift X here to here. There. I think in reality what it would probably be is the other side would just be a ground plane and I punch vias through to get to ground or something. I don't know. How does this do it? Whatever. So ground plus 5-volt. It's fine if that's there. Yeah, this is fine. It'll probably yell at me about like unconnected traces or unconnected pins, maybe. Unrouted 20? Oh, because these aren't routed either. Okay. Yeah. Anyways, I'm gonna take a screenshot of this. I'm gonna post it up on Discord and let people roast it. I'm gonna post it in my stream discussion and in the Absalom Club server because there's a lot of designer folks in there. First, I gotta find the screenshot. Oh, there it is. Okay. Roast my routing. Okay. All right. I am going to call it here. We're almost at 3 hours anyways, which amazing. I got a that's actually not bad from one person on the Absalom Club server. So, hey. And yeah. This is exciting. So, one thing that's probably going to have to change now that I'm thinking of it, unless we have all the data pins for the matrix down here, is that this is blocking this entire row of pins. This is blocking this entire row of pins. And, there's just a lot of like, you can't get out of here without without vias. But I'm guessing these are mostly going to be data pins. You got ground, 2 grounds, 2 plus 5 volts. We need 4 data pins. So if there are 4 data pins out of these 6 pins here, 7 pins, we're fine. And I'm assuming the next step of the process is like, and now you route your data pins for your matrix. But we're gonna do that tomorrow. So we're gonna continue this tomorrow. This has been fun. I'm glad I pushed through the frustration because I almost called this like 2 hours ago. I was just like, I can't figure out why I can't see anything. I'm getting frustrated. I'm fighting with friggin' OBS. I just wanted to. Yeah, and it wasn't banana time because I'd already eaten just prior, so I wasn't like low blood sugar or something. But anyways, I'm gonna call it for today, and tomorrow we'll continue on the tutorial. If there's any feedback I get from the roasting of the routing, I will incorporate that, and then yeah, cool. Anyways, thanks y'all for stopping by, hanging out. Thanks for your patience as I flail at this. This has been a great learning experience. I hope other people learn stuff too. If not, that's fine. But if you just, schadenfreude watching me flail at this, that's also fine. Anyways, I will see you tomorrow for more of this. Have a good one.